and put everything on the key punch and send it into the little reader thing. You know, you always had to deal with that guy that was like the one that ran the computer. Was always a pain in the neck to deal with. So
It was his domain, though.
it was, and there was always the same sort of person, no matter where you were. It was the same personality.
Different face, but the same person.
Yep.
Yeah, I get a kick out of some people that Best Buy and so forth. When I go look at some sort of computer program or something like that. Well, I don't know if I ought to tell somebody your age or not.
Tell him,
And I said,
man.
well, young man, what were you doing in 1961?
Yeah.
Well, I wasn't born yet. And he said, well, I was developing software for the Department of Defense. Now, I think I can handle this.
So there. Yep.
Yeah, I killed one sale for him up there. They had some guy and his wife were in there looking at computers. This is 3 or 4 or 5 years ago. And they had picked out a printer and he picked out a tall computer. And the salesman said, well, how about a monitor? No, we'll put that off until later. We're gonna just get this computer at the printer for now.
Yeah, that's not gonna
And the
work.
keyboard. And so everybody wanted to sell it to him that way. I told his wife, said, I said, you know, you got a little problem there.
Yeah. Yeah, well, you know.
Well, what do you think of this shirt, Gary? Hey, my brother's forgetting my sister-in-law saying that.
Yeah, I've got one that says,
You wanna use the.
I think I'll just use the camera since it's more interactive. I'll just start with the camera. I'm also doing it on YouTube this time.
Okay, I'm gonna go ahead and put the slides on this machine then.
Sure, yes.
Oh, it's loud.
You see, Plea was like, what, 6?
Yeah, the guy came to unlock it when the other group was in here, and he's like, "Do you guys need this?"
Oh,
And I'm
that's
like,
for
"No."
a small monitor. And then
It is now.
Is there?
yeah,
Used to never-
it's on the minor plan, oh, it's actually a floor plan, but it's also monitored now as a asteroid microphone. Well, it used to be that you couldn't turn in data, but it was a major plan, so that had to go a different route.
Yeah.
But now it's through the minor planet center, just like everything else.
And it's got.
Company object. Yes. Hey there. You guys need a mouse and keyboard?
Yeah.
I think we do, yeah.
I broke your security now.
I took off the Velcro.
I don't mind when people mess with it, they actually know what they're doing. Is that our keyboard?
Yeah, I took it out of the back. I wasn't gonna let the Velcro stop us. Come on.
That's awesome. Where'd the mouse go?
Oh, I already got that one.
Yeah, it's right here.
I got the keyboard now, so already.
Oh, okay, that's perfect. Yeah, I would have been up here earlier, but the schedule was a little wonky, and the other group was here later than I was expecting, so.
Yeah, no
We were
problem.
expecting to.
So we on the air yet, or?
Yeah, we are. I just have to adjust the camera a little bit.
Okay.
I had 2 big problems with that spectroscopy thing. One is we should have done it in Arizona or someplace in the desert.
I need something to hold
Because
the
we used
camera.
in prison.
Uh-huh.
Made a rock slide. Guess what happens to that?
Oh,
In the humid atmosphere.
Yeah.
Yeah.
The other problem is that one of the boron trichloride we were working with.
Uh-huh.
And in the presence of atmosphere, you only have fluoric acid and trichloride and hydrofluoric acid.
Ooh, that's nasty.
Kind of a fun
We
thing.
had a hose broke on me one day while I was using that. I had a gas mask in the room. just
Okay,
in
do we have
case.
anybody on?
I grabbed my coat, put it on backwards and put the gas mask on and walked out into the hall.
But they might
I was right in the
also send
center
a
of the
message.
3rd floor of this physics building. As I walked into the hall, the bell rang, and all these classes dismissed, and they saw this character coming out with a gas mask and there was panic galore.
The only thing that I kind of would be similar to that with me was when I was doing food chemistry for OC Meats actually. And our illustrious lab chief decided that we need to use potassium cyanide as one of the agents, and we looked at that, we looked at him, we said, ain't no way, you drop of that and the whole floor's dead.
Yeah.
Stupid people.
Okay, all right, I guess we're ready to go ahead. Sorry about the delay, but I think we're all set to go now. Okay, welcome to everyone. I guess we got a couple people at home, so welcome to those as well. Before we get started, are there announcements or anything Gary's mentioned?
Yeah,
Something?
I had a little email that I sent 2 weeks ago to our person that's making our 27-inch F3 mirror. And I asked him, I says, well, are we still on for December? Never got a reply, so I sent him another email. And he replied back and he said, oh, yeah, sorry I didn't get back to you. Looks like we're about 30 to 45 days away from finishing the mirror.
That's later than we thought, right?
Way later.
Considerably later, yeah.
And then he said, and then we can't seem to find somebody that's gonna coat the mirror when we're done with it. They said that the quote that they had was 30 to 60 days out after he gets done with it.
So we're looking at
February, March.
Okay. In the meantime, doing the kind of physical restructuring on it, is that gonna wait till the mirror cools?
Yeah, we're gonna postpone that.
Okay.
I originally had picked a date out of the hat and said December 10th would start, just to give me a couple weeks before the mirror came in. Well, I think we can postpone that till February 1.
Okay. Well, that's unfortunate, I guess. but,
Yes.
Can't say I'm terribly surprised. You know, it seems
The
like
good news is my mirror's done,
okay.
There you go.
but it's gonna be a couple more weeks before the coating gets done on it.
Was it just being recoated or was it?
No, it was being resurfaced.
Yeah.
The Strel on it was 29, I think, when I sent it to him. And he said the Strel now is 97.9.
Okay.
So it sounds good.
Yeah.
We'll see how it looks.
Well, speaking of telescope making, we got an email earlier today, I think, from a high school student in Shawnee, interestingly enough, who expressed some interest in that.
And they've got nobody in Kansas City to take
Yeah, I
care of
was a
it.
little surprised by
It's
that.
like a 400 or 500 member club over there.
Yeah, I was a little surprised by that. But did we respond, or should I respond to him?
I mean, I don't think anyone responded yet.
Okay, I can respond back. And I don't really have much to say about telescope making. You know, that's not one of my skills. But
Russ has
Mark
been making
is-
telescopes for a while.
Mark Weiss is really interested in that kind of thing. And
Yeah, well, he's got a group going there that he's going to be making. And I saw he's had an ad in Astromart or Cloudy Nights or something that was requesting 6-inch mirror blanks
I think
for
his,
a class.
I think his that Civil Air Patrol group that he's like the commander of, or
That I'm
something.
going to give a talk to December 14th.
Yeah, I saw that. I may sit in on that, but
Yeah, well,
I've got an 8-inch blank, but I figured that if somebody wants it, it's not coated, but it's figured.
yeah,
Mark got it.
A little down.
yeah, he might.
The size was it? The size? 8. Oh, not 8. Maybe a 10-inch.
Yeah. Well, I did prepare some stuff for tonight. I know we got kind of a small group, and most of this is probably going to be like definitely, singing to the choir. But I put together a little bit of presentation on December skies or winter skies because they're something I really like. So we can go ahead with that or not. It's kind of up to you guys, I guess, and folks at home.
That's fine.
Okay. Well, as I said, I kind of liked. I thought I'd start off with some highlights as we often do. Do we need to shut the light
Didn't
off?
lights?
There I go. behind the door.
I found this little video too, so I thought maybe this is really short. I thought maybe we might let's go ahead and show this one. I think the Space Telescope Institute puts these things together, these little videos, and I think we've looked at some before, but let's see, where's the brown? And one of the reasons why I kind of like them is they put nice music on them. So I don't know if we'll be able to hear the music, but we'll go ahead and start.
I think you can.
I'm hearing it a little too much. Well, you get a little Mozart with this too. So. So,
They ran the sky backwards.
did they? Well, you know.
From a visual observer standpoint, it was backwards.
Well, Peter, it's October now, and the nights are getting longer, and we should start off with the inner solar system. And Mercury, this reaches greatest eastern elongation on the 1st of October, and that's
Okay. So they ran the sky backwards, which you think these people would know better, but
Well, they weren't looking through a telescope. They were taking a more
They were-
traditional view.
yeah, you know, as if they were actually
Yeah.
watching.
They don't look through telescopes.
So one of the things I liked about that, several things I liked about that video. First of all, I've always, by far, my favorite time of year, and a lot of my sky watching as a kid, we had this really huge flat rock out behind our house, and kind of looked off to the north, and it was a great place to just kind of lay there. And you know, we were up in the mountains where the air was very turbid, but also very clear, so stars twinkled a lot, but you could see a lot of them.
Yeah.
And it was always kind of fun it was always my favorite time of year. And I also like the fact that it showed, you know, a lot of these, of the constellations that many of them are, of course, fairly familiar. But one I wanted to kind of focus on a little bit, partially out of just interest and partially out of, I guess, personal experience lately, was this one, Cassiopeia, which I think it's one of those ones that almost everybody recognizes, but the story behind it is not, it doesn't get a lot of attention sometimes. So I thought maybe we would just take a kind of a focused view on it. In terms of where it is, tends to be, you know, it's right around the North Celestial Pole, and it's actually visible at a lot of times of the year, which is actually one of the reasons why it's important kind of astronomically as well, as we're going to see here. But I thought the story behind it is always very interesting. So the full name of the constellation is Cassiopeia the Queen. Cassiopeia was the queen of Ethiopia, and her husband was Cepheus. And one of the things about Cassiopeia, I often see her depicted artistically something like this. A rather attractive woman, but grooming herself and looking in the mirror. And the story is that she was, both she and her daughter Andromeda were very attractive women, but very taken with their own looks. And at one point, Cassiopeia bragged that she was more beautiful than the Nereids, the sea nymphs. And that angered the god Poseidon, who did not like his sea nymphs, his beautiful creatures being compared to this mortal woman, even if she was a queen. So the story goes that as a punishment, Poseidon threatened the king and queen, and the king's response was to give his daughter Andromeda to be sacrificed to a sea monster. And so Andromeda was chained to a rock in order to let this sea monster come and devour her. The whole thing was broken up by a hero, Perseus. So here's a painting from the Louvre, which is a name in French I'm not going to try because French is one of the many languages I don't speak. But this is a picture from the Louvre, and it kind of shows the aftermath of all this. So here's the sea monster down here. Here's Andromeda kind of freed from her shackles. Here's the hero, Perseus, who went on to marry Andromeda. And here's the king and queen thanking the king, who seems to me to be a person of not a whole lot of moral fiber, if he would put his daughter forth to be devoured by a sea creature. But anyway, so this is the story behind all this. Of course, Andromeda is one of the galaxies, and they're all kind of together up here in that part of the sky. So there's Cassiopeia, there's Cepheus, who was also, you saw him in the video, Perseus, and Andromeda.
Is that a Tyrian page? Is that a page out of a Tyrian catalog?
I think it is, actually. Something I found online, but I think that's right. And the other reason, though, I was kind of interested in talking a little bit about Cassiopeia, and this is strictly personal, we'll get to that here in a second. Here's some of the kind of noteworthy objects in Cassiopeia. It seems to have a lot of open clusters in it. So here's a couple of open clusters that you can see. There's M52 right there. and in 103 should be. So these are the Messier objects that are in there. This is one I thought was kind of interesting. There were two nebula that are referred to as the Heart Nebula, and this one's recent enough that it's in the IC catalog. IC 1805 is the heart, and IC 1848 is the soul, and I guess they go together, and probably something to do with beginning piano players or something. But at any rate, these are a couple of the other nebula objects that are there. But the reason why it's become sort of on my radar lately is it's also one of the things I've been kind of working on lately is learning how to do photometry. And in order to do photometry, astronomical photometry, you have to often transform the measurements that you make.
Yeah.
So photometry is just the measure of the magnitudes of objects, right? And the colors as well. And it depends on having a set of filters that you observe through. And again, I'm sure most of you probably know all this fully well, but those filters are often even filters meant, even though they're standardized, like the Johnson-Cousins filters are the standard UV-BRI set, they are often not, in fact, very rarely, in fact, probably never really identical with each other, right? So a set of UV-BRI filters, even from the same manufacturer, like Astrodon or one of the really good manufacturers of filters, will be different. And so the way that this is handled in data submitted to organizations like AABSO, the American Association of Variable Star Observers, is to transform the data. And so the way this is done is that standard fields are, there's, I believe, 7 standard fields are imaged, and then you compare what you get with this very well characterized set of standards. And one of those standard fields is this one, NGC 7760, which is in Cassiopeia 3 there.
Yeah.
So this is something.
These aren't Landau's.
No, these are not Landau fields, but
Okay.
they're Landau fields are for determining if your magnitudes are accurate, right?
Yeah.
Well, I think they can be used because they've got color information also.
Okay.
Yeah.
Well, and the deal with these, and this is actually something this has become interesting to me because I just finished up a class of learning how to do this stuff, is you kind of select a series of these comparison stars or these standards that have to encompass a fairly wide range of colors. And that's one of the reasons why why the organizations like AABSO have done this. So
is this Hendon's work, maybe?
The person I think that really started it was Arnie Herndon.
Okay. Yeah.
He's the one that I think led the effort.
I met him in Boston.
Did you? Did you meet Ken Menzies by any chance?
No.
He's the one that taught the first class, not the one that I just completed, but the first class. He was an interesting dude. I bet he's kind of a fun guy.
Well, this was more the spectroscopy thing, so it probably, and he's probably more in photometry, isn't he? Like
Yeah.
Yeah.
And there's been a couple of the SAS conferences in California too. So.
Yeah. And AABSO has actually established what they call the Bright Star Monitoring, the BSM network. And some of the imagery, actually one of the images I'll show here in a second is from that. But what I'm hoping to do is get my telescope, my telescope set up at some point out of Farpoint and be able to characterize it with these fields and get it kind of tuned up to do photometry. So that's been working on that goal here for a while now, and progress has been slow, but it's happening. So anyway, this is one of the, and this is something that's more than just contribution by amateurs. This is used a lot by professional astronomers as well as a calibration field. So these are some of the variables that are. This is actually an image that's from the Bright Star Monitoring Network. So it was collected on September the 29th. And this one has been captured through a V filter. So this is a V filter, and there's a B filter one as well, but I didn't bring that one. But it shows that NGC 7790, that cluster of stars there. And everything that's on green here is a variable star that's in the AAVSO's variable star catalog. And this particular software right here is called VFI, and it's kind of the standard tool that a lot of members of the AAVSO use to do their photometry. And I didn't like it at first, but I've kind of come to appreciate it a little bit more. And so anyway, the reason why I'm kind of talking about this, which some of you probably already know, is as part of this class, I the other day reported my very first set of data. And so this was very exciting to me. I know probably to everyone, but this is very exciting to me. So I reported some transformed and non-transformed data on a couple of variables, CG, Cassiopeia, and ER. And this was the results that got sent in. So this one was a transformed one, and this one was a transformed one. And I believe this was the V filtered one, and then the transformed V. So I was pretty excited by this. Hopefully not tooting my own horn here too much, but and I'm really looking forward to being able to capture data on our own, to be able to capture some stuff at floor plan. Kind of hoping that others will get interested in this as well. But anyway, that's one of the reasons why Cassiopeia has been on my mind lately, because it was the place where these were collected. So other things that are happening in the sky, probably the most obvious one tonight is tonight, I guess, and tomorrow morning is a lunar eclipse. I guess it reaches its maximum at, it would be 3:02 a.m. here.
Yes.
This would be Eastern time, so Central time would be about 3 o'clock. I honestly don't know if I'm going to be up for this, but
I will be.
are you gonna? Yeah. But anyway, it's supposed to be a pretty good one, and it looks to be a pretty clear one. So.
That's Central Time?
I believe these are
Eastern time.
So you just take an hour off of that for Central time.
3:02.
So our center is 3:02.
Yeah, it looks like it'll be kind of, you'd still be able to see a little bit of it towards morning, but anyway, I don't know. I've seen maybe 3 lunar eclipses, so it's but anyway, it is an option. So one wants to see this, it's tonight. Okay, so that's kind of sort of the what's happening in the sky part about all this. And the other thing I was going to talk a little bit about, and again, this is, since we're kind of a small group here, it's sort of what you want to do, was talk a little bit about spectroscopy, largely because, as some of you know, we've kind of started a little project to build a spectroscope, and Gary took some training in spectroscopy just last week or the week before?
Last week, yes.
Yeah.
It seemed like 1,000 years ago, but
Yeah. So it's kind of up to you. What do you all have any preference on what you'd like to do?
Well, one thing I'll put out there is that, and people might be a little bit upset at me because I bought 2 Astrodon photometric filters, a red and a blue, and paid $250 each for a 2-inch filter, which is
That's not bad.
pretty cheap.
Yeah.
The filters are in really good shape, and it was the woman from Manhattan that you and I went to.
Right.
I went back there with Ford. He bought the 16-inch.
Who did?
Ford. Mike Ford over at Holton.
Oh, okay.
He bought the 16-inch, and I bought the filters. So he paid $5,500 for that 16-inch.
That's a price.
That's pretty good.
Yeah. Did she sell the?
And it was the ACF version, so it had better optics.
Has anybody bought the dome?
No, it's still open for you.
What are they on for?
I have no place to put it. And no money to buy it with.
I don't know that they know how much they want.
Yeah, I don't know. I mean, I was surprised that she sold him the 16-inch for $5,500, which is pretty reasonable.
Yeah, that's not bad.
But I can't complain because I got the filters. And the filters, by the way, now Chroma was at the convention, and they had a display going. And I talked to them a little bit, and some of the controversy was that there was a lot of even Astrodon filters had a small light leak in the ultraviolet. And for people that does demanding work, that's kind of a sin.
Yeah.
So they were kind of scratching their head trying to figure out what they could do about it. Anyway, I talked to a woman. I says, "Man, I can't really afford these 2-inch filters. They're like $650." She says, "Oh no, now they're $850.
It's pretty,
$850 per filter."
it's pretty discouraging because I would really like to get a B filter,
Yeah.
you know, and I'd actually like to get the full set at some point, but
Yeah,
B particularly because,
I've got a BVR now in 2-inch.
yeah, and then your V is still in my camera.
Oh yeah,
That's a 1 1/4.
that's a wonderful, right?
Yeah, well, I mean, a lot of the needs for data need the B minus V
Yeah.
color transform, and
Right,
you
those
don't
are
have
the big
the B,
ones.
you're kind of,
And the V minus or the VR is actually used for asteroids a lot.
Yeah,
So,
that camera I bought from Brad Hutton had the filters in it.
oh yeah, yeah, that's nice.
there is actually a way to trend to if you've got the the RGB filters, you can transform them into Johnson Cousins equivalents.
Yeah.
It's a little bit of a black art from what I can tell.
Now what? I'm not following what you're saying.
If you have like the RGB filter, like the ones that came
Oh,
with my
this the standard RGBs
Yeah, right,
that they use for color.
just color photography.
Yeah, yeah. Well, I looked at that. God, what was it? Astrodon's Generation 2, which I have a set of, by the way, is really close to Sloan filters. If you take a look at their displays on
The curves?
yeah, the curves are really pretty close to Sloan filters.
Yeah, that's those.
And that may be what they're talking about, that would transform.
Yeah.
Well, I suppose you could generate calibration curves for most of that.
Yeah.
Might
Take a
a
little work.
lot of effort.
It would take a lot of work.
Yeah, I haven't really dug into how to do that, but it was one of the things that came up in this class that just took. The class unfortunately got a little disorganized because the guy that taught it lives in Northern California, and apparently he was dodging fires and storms and all kinds of issues while he was trying to teach this class, and power going out and all that sort of thing. So he was teaching in
You should know better than to live in that part of the country.
Well,
You know, so should the rest of California.
try to tell him.
Do you remember how it was when we were in early days? They wouldn't let you in. We don't want people out here.
Well, now I think they're trying to keep people from leaving. But anyway, well, shall I kind of want to run through this stuff? Or?
Sure.
I mean, again, this is probably stuff that is not really going to be too far out of your own wheelhouse, but I just thought I'd talk a little bit about, since we are in the process, we think, of trying to develop build this spectroscope, a little bit about what you kind of do with these. And of course, the thing that, to me, that makes spectroscopy kind of challenging is that, photometry, you're basically just trying to measure the magnitude of a stream of light.
Yeah.
With spectroscopy, you're breaking down the spectrum into these really fine little kind of bins, and you got to get enough light in each bin to be able to get a signal. And so it makes spectroscopy, particularly, I would think, of really faint astronomical objects, kind of a challenge sometimes. But basic idea, of course, is you break the light down into a spectrum, which is a pretty common idea, I guess. The reason why it works actually gets pretty deeply into the physics of how atoms and molecules work. And like I was mentioning earlier, I brought a little bit of library here for this, and I have several books on this, and these sort of range in order of difficulty, I guess. So these two are very descriptive. They're actually pretty good. They don't really have much in the way of math in them, which good or bad, depending on how you feel about math. But they do a pretty good job of sort of descriptively talking about how how to translate the physical process into spectral analysis. This one's kind of somewhere in between, and there's another. It has a companion with it that's like a library or an encyclopedia of spectra that kind of would help you interpret that. And then this one's a lot more similar to the kinds of things we looked at back in the day when we were studying this stuff. This goes into quite a bit of I think you really have to get your chin strap buckled in order to take this one on. But I between these I think it does a really pretty good job of kind of explaining how the signal comes to be. And of course, if anybody wants to read one of these things, I'm more than happy to loan. But anyway, the basic idea is we have this model of the atom, the Bohr model, and the idea is that all these shells, these orbitals, are basically energy states. And the whole insight of all of this back in the 20s and earlier, actually even back in the 1900s when they were coming up with all this, is that the electrons that are around the nucleus of an atom can be in any one of these states, but not between them. And they kind of jump from one to another. And it takes energy to make them go from a ground to a higher state, requires energy. And when it goes from a higher state back to a ground state, then there's an emission of energy. There's either an absorption or an emission of a photon. And those happen at very, very discrete wavelengths. It's quite specific where a particular atom will absorb or emit in order to either jump to a higher energy state or fall back to a more of a ground state. And that's really kind of the fundamental notion that produces a spectrum. So here's kind of an example of that. This is probably the most familiar example. This is the Balmer line of hydrogen. It happens when you get a relaxation from the down not to a base state, but to a lower energy state, and it emits a photon at 656 nanometers, so a red photon of red light, basically. And of course, there's a bunch of others as well. So, a lot of those really tearfully difficult classes I can remember taking way back in the day were about learning how to calculate all this crap, basically, and this still produces a few nightmares from time to time. But these are the kind of spectral lines that are associated with hydrogen. So the Paschen one and the Balmer one are probably the most widely one, and the Lyman one as well. And so if you put all this together, basically, what you end up with is a kind of a pattern of either emission or absorption that is diagnostic of the atomic identity, I guess, of what something is. So this would be the emission spectrum of hydrogen, and each one of these lines that you can see here represent one of these series here. So there's the Balmer line out there, and so on. And so if you take the spectrum of an object and you see a pattern like this in there, then it tells you there's hydrogen there. And you can kind of look at the nature, like whether the lines are leaning over or split open or stuff, can tell you things about the motion of the object or its magnetic properties, or this Zeeman effect when the lines get broken apart, and that's a magnetic thing. So a lot of the physical information that you get about anything, really, stars, any astronomical object, largely comes from analyzing these spectra. There's a couple different types of spectra, depending on the situation that produces it. So continuum spectrum is when you just get a emission that's across the continuum. It's basically emission across the entire range of the spectra. And that's largely dependent on the temperature of an object. The hotter something is, the more energy it emits, and at shorter wavelengths, basically. Then you can get emission spectra, which is kind of like the one we saw here. And that's basically what happens if you get a gas that heats up, or you get an object that heats up enough to actually produce those changes in energy state. Or you can get I'm sorry, that's a transmission spectrum. Or you get an absorption spectrum, which is if you get a continuum light that kind of passes through some medium that produces the change the other way, basically causes a change to a lower energy state. In that case, you see what look like missing gaps here in the spectrum, and that's where that energy is going to producing the change of state in the other direction, basically, and back towards the base states. And these are both used to kind of characterize the physical properties of something. So that's atomic spectroscopy there. It's also, you can have molecular spectroscopy. In astronomy, I think most molecular spectroscopy is planetary because most objects are too hot to really form molecules. It's only very unusual stars that'll have molecules in their atmosphere.
There is molecular gas too in spots in
Right.
some instances.
Well, that's one of the reasons why everyone interested in like these BE stars, right?
Yeah.
Because they have molecules actually in there. They're cool enough to have molecules. The thing about molecules is they have a lot more ways of changing. They can kind of bend and stretch and wiggle and vibrate and all this stuff, and that produces some spectral properties as well. So there's stretching and rotation and so on. And so what that usually means for molecules is that instead of these really crisp lines that you would associate with atomic spectral processes, they tend to be kind of wider lines. And this is something I guess chemists are often a little more used to working with molecular spectroscopy. Anyway, so that's kind of the quick and dirty look at the sort of science behind all this. So what a spectroscope basically does is it takes a source light, breaks it down into its component spectral parts. They're always shown as, often shown as being done by a prism, which of course it will, but in most applications the dispersion is actually done with a grating. I actually brought our grating here. This is one that we got from Edmonton. I bought this, I don't know, about a year ago, I guess. But there's a grating. And what they really are is just some little piece of really high quality optical glass with just tens of thousands of really, really fine little lines ruled into it. And the lines have kind of a sawtooth, if you could see them up close. They have kind of a sawtooth look to them. And when you pass the light over it, that kind of breaks it down into the spectral components, but in a much more, with much greater resolution than most, probably any prism will. Although there are certain types of spectroscopes that combine them. They're called grisms, I guess. They combine the properties of a prism and a grating. But the only ones I really know much of anything about are ones that use a grating. And my experience with them is in spectroscopic cameras that have been made to point down at the ground. So they're looking at reflectance spectrum, which is a different kind of beast entirely. But anyway, that's kind of, in a nutshell what a spectroscope does. It basically breaks down the light into these spectral components, and you can actually see these patterns of absorption and reflectance, all that sort of thing. So amateur spectroscopy is kind of having a moment now, apparently illustrated by the fact that the AAVSO and now running workshops in how to do this. And I was pretty surprised by this, and especially surprised to find that the equipment that you need for this is not really all that different than what would be required for pretty high-end astrophotography or photometry or any of these other kinds of common things. So this is a setup by this guy Ledbetter who runs this Three Hills Observatory, and you can kind of see that what he's got here is a pretty modest-sized telescope with a spectroscope attached to it, and he's used it here to look at a potassium line in an eclipsing. This is an eclipsing binary, and this is part of a of a pro-am collaboration to kind of understand this star with this particular star. So anyway, this is some of the data that they collected. And this is actually pretty impressive. I mean, the resolution on this is not comparable to, some of the professional instruments, but some of those, particularly the things like shell spectrographs and the ones that have really, really, really high resolution that cost hundreds of thousands of dollars to, if not more, to build. This particular one, I think, is a commercial one that would be around 5,000 or 6,000. So the prices on these are high, but they're not, they're within the means of a serious amateur. So here's some of the examples. This is one of the more commonly used ones. This particular one, this is the one now that isn't Shellyak the company that's starting to sell the guts of this thing?
Yeah. Yeah, they've got the optical components and then some of the mechanical, and then they're putting it into a 3D printed base. So
right. Yeah, so this is one you could buy off the shelf. I think these are getting really hard to find. I don't know if maybe they're not manufacturing them anymore, but
probably a lot of them on board ships.
Right. Yeah, but I think the price I saw on this one was about 3,700 pounds. This was for sale in Britain, so whatever that translates to in US dollars.
4,500 to 5,000.
Yeah, but I mean, this is obviously not a trivial purchase, but on the other hand, it's also not something that's out of the range, like I said, of a pretty serious person or a club or something like that. So this is, you can kind of see here's the base thing. Here it is sort of attached. I think, as I said, I think the unit around here costs about $5,000, and by the time you've added all the bells and whistles that you need to actually collect data with, it's probably closer to about 8 or 9. And that kind of brings us to some of the things we've talked about. And I think it's kind of appropriate that we had the presentation last month about 3D printing, because this is the beginning, we hope, maybe of a build of a spectroscope. This is something that Russ printed for us, and this is called the low spec. And
if we want people to see you, we have to
You're
turn
gonna
the
have to turn the lights back on.
Oh, okay. And I thought we could just kind of take a look at this, because I think we have most of the parts for this now, if not all the parts for this. But this is something that you
Some
find.
of the parts will have to be modified, but
Yeah. But optically, it's laid out very similar to the Shellyak instruments, kind of internally, and I think we have all the parts for this. So, and this is an example of a spectrum that was collected. This is Vega, and you can kind of see some of the spectral features on this. And this was actually taken with a really relatively modest telescope. This is a 100mm telescope, so not a lot of aperture here by any means. So anyway, that's kind of it. So I think, Gary, we talked about this earlier, but do you really do we want to? I know we've got the parts for this. Do you think it's
well, here's the thing, and this is really what I'm thinking about, is that this may not be top of the line, but it will be something that we can play with, get a feel for, and then if we decide to go for a more expensive unit, we can do that.
Well, I'm kind of wondering,
Because you've already got the cost laid out in this.
Yeah, and there's probably, I don't know. I think the glass for this was about $300.
Oh yeah. See, and I think the mechanical parts that I bought, the micrometer and all that stuff, was somewhere around 125, 150.
Yeah, and I don't know what the cost for.
$20.
So, I mean, I would.
Good deal.
How many
It
hours?
did take like 2 weeks.
Yeah, I was gonna say,
This is a pretty.
It's heavy.
Yeah, I mean, we can kind of send this stuff around if you want to take a look at it. But there's one of the things that was a little bit difficult for me was I had never dealt with this company, Thor Labs, before. Most of the optical stuff I've bought has been through Edmund And no particular reason, but I found out that the store lab people, they're really easy to work with. My original plan was to buy them from this company in Germany, and it turned into this really difficult process of dealing with Germans. And so I kind of went back to Thor Labs, and they were pretty easy to do. Every time they send you stuff, they send you like snacks with it as well. So my box of optical components also showed up with like, Cheez-Its and Cliff Bar or something. And I thought,
Well, they know their audience.
I was gonna say, that is kind of brilliant, actually. Yeah.
Would you send me a link to the website?
Yeah, if you need to order stuff from them and you're hungry, kill two birds. But anyway, these are just kind of small little lenses and mirrors that go internally. The heart of this thing is the I don't know if you guys at home could see.
Yeah,
this,
is that
but
a curved grading?
There's the. I don't know. That's a good question.
There's an arrow on it.
Yeah,
When you said it, the grading,
Curved. So you.
well, yeah, I mean, and scientific.
Oh.
Yeah.
Problem
I
I
used
used
to get stuff
grade,
from
didn't
them,
it?
I had it for years.
Yes, correct, square. Maybe long spectrum scale.
No, yeah.
Doesn't really
What-
look that way.
Did you use a grading with it, or
Couldn't agree.
is it like this one?
No, the one back from the 68
Oh, okay.
catalog, the ones they had in 68.
Yeah,
I don't think it's the same.
They were about 1,000 times cheaper then.
probably.
Like $1 back then.
Here's all
Get my
the,
lunch money to buy.
here's all the other,
I had to get my lunch money, but, oh, yeah. This is,
I actually had one of my classes once make a little spectroscope, and we used a CD, a
Yeah.
DVD.
Yeah,
You peel off the,
DVD works better than a CD.
it's got to be one
It's
that's
finer.
never been written to, but you peel off the silvery part, the part that actually
Yeah.
is ruled.
Yeah,
And it
how are we
works.
gonna get all this put together?
but they had a science fair, I won like.
A lot of parts.
Yeah, that's cool. Were the kinds that look like a little
On
slide?
the slide.
Yeah, we used to have those I remember those. You kind of look
They were
through
like-
it.
That was a lot of money back then.
Yeah, I remember those.
So what's the grading, what's the line spacing?
1,700.
17?
Yeah.
That's
My lunch
pretty
money
good.
was $2 a week.
Yeah.
So they
Yeah.
had my lunch money.
If you get it more than that,
You
you're
went
gonna have
hungry?
a tough time with your signal.
Right. Well, some of the stuff that looks really tricky about all this is like, keeping the objects on the
Yeah.
slit and all that
Oh,
kind
Because
of
that slit is a line, it's a few microns long,
Yeah.
wide, but it's
The-
not very wide at all.
I think the slit wheel is in that blue box there.
Theoretically, you're supposed to keep the slit just so that you just get the star enclosed, but not hitting on the edges,
Yeah.
but close to that edge.
Well, one thing we might want to consider, since it looks like there's going to be a little bit of delay in getting
Oh,
since it looks like there's going to be a little bit of delay in getting the Tombaugh mirror, maybe we want to work on this
Sure.
in the meantime.
Well, yeah, or, several other projects.
Yeah.
In between, because who knows if February is gonna be right.
Well, I know I go a little bit of time over the break. That's a little more. Well, I'd also like to get my telescope set up out there over the break.
Yeah. Well, that's,
This mirror is a little bit like our film, they were about a year late with that.
Yeah.
Yeah.
I know. I know.
So frustrating. And
Well, one thing I can see we're gonna have to do is we're gonna have to clean up some
Yeah.
edges
Yeah.
here.
Mm-hmm.
There's a few
Yes.
edges that are, yeah.
I thought originally I was like, maybe I should clean it up, but I'm like, I can mess it up while trying to clean it up.
Well,
so I'll probably leave
it's easy
it.
enough to do, that's right.
Yeah.
you have your own printer.
He does.
Mm.
There's lots of people out there that are building these, and there's like websites and
And there's a lot of people that have considerable success with them already. A lot of people have done the latest Novas.
Do you think we need to kind of scrap or at least change this to the more recent design, or do we want to just stick with the?
Oh, go from 3 to 4, for example. I think a 4 is out, but not. I don't know if it's completed yet, but I know some people are working on 4, and I think it's getting close to being done. So I don't know.
Yeah, and this one has a guide camera and then a data collection camera. And I don't know.
Yeah.
Do we have cameras for that?
We actually probably do. We've got a 183, which is, I'm sorry, an IMX 224, which is a lot of people I noticed are using the 183s.
Yeah.
Because they have such small angstrom pixels, and they're back illuminated, so sensitive. But when you say sensitive, when you go to 2.4 micron pixels, that's not very sensitive.
Yeah.
Even back illuminated, you got no surface area to work with here. So it's a trade-off always.
Yeah.
And actually, the ST9 is not such a great thing, but I've got an ST8.
Yeah.
But but I think they both use 9 micron. Oh no, the ST9 uses a 20 micron pixels, which is pretty big.
Right.
And that would work for kind of the stuff that we need to get a lot of, that's very faint.
Yeah.
And we want to get some data on it.
Do you think that you'd be able to, those cameras are really heavy. Would we need to like build some sort of a brace that kind of
Yes.
connected all this together
Yes.
so that it wouldn't be?
I've
there would
seen
be no
some
flexion?
examples of that, and I thought about that too. It wouldn't be anything at all to build a brace for it, so we should do that.
Okay.
And I would recommend it doing out of thin steel rather than thick aluminum.
Yeah.
And the reason why I say that is because of the coefficient, temperature
Right.
coefficient.
Wouldn't, yeah, especially if you're going to be in the
And if you've got a
broad
long,
temperature range.
if you've got a long brace, that's going to matter.
Yeah. Yeah, if it's going to be used under a lot of different temperature conditions, then you want something that's not going to be.
Right.
Yeah.
Anyway, we can figure all of that out. That's
Thermal
not,
expansion makes a lot of difference when you deal with something like this.
yes, absolutely.
It doesn't take much to get things out of alignment, especially if you're trying to,
So did you say you got a slit?
Yeah, the slit wheel is in here. That's that right there.
Okay.
There's numbers on the edge. I guess they're different widths inside,
Yeah.
but can't really tell by looking at it. I don't know.
But, okay, is there something that goes in there? Because I don't think this is all of it. When we start talking about 10 micron, I don't think that.
Well, I think, my eyesight isn't quite good enough.
I don't know. It's a good question. I think
Because
this is everything.
I'm thinking that slit is, when you talk about 10 micron or 20 micron slit, that's way bigger than that.
Yeah, I can't see how you print something that small.
Well, you wouldn't.
don't think you can.
You wouldn't.
Because you're,
There used to be a surplus store. Oh gosh, what was the old surplus place that you could go to get some astronomy parts?
Here?
I can't think of what it's called. It's
online.
yeah, online.
Oh,
You know what I'm talking about. Most people do.
like
Anyway, they were supposedly had some slits. I don't know if they've got any left.
Was that Owl?
like C and K surplus or something.
I can't remember.
Well, probably one of the things that we would have to kind of start off with is just make sure we got everything.
Yeah.
Which I know, I looked through it all at one time, but then, time passed and.
Now, because what I've seen with slits have this kind of a bigger base at the bottom, and then the actual slit goes up from there.
Okay.
And that width of base is allowing you to get everything kind of lined out and centered, and then you shove that back up that slit so that your star then goes up that slit where it's really narrow, which
Okay.
is the narrow part. This is probably just the starter of each set. And depending on what slit you've got in front of this, is what, how you dial it in, I guess.
Okay.
I don't know. I'm kind of guessing a lot of this stuff, but it looks like to me that this is not small enough at all,
Okay.
nor is it rigid enough. So
Okay.
that much still we have to look into doing.
Guess
finding the
we
slit.
have to look at the instructions.
Oh, I hate that.
Yeah.
You expect us to read too?
Come on. Are we English majors here?
Yeah. Does kill.
Just because you're meeting in a library.
Yeah, that's as close as I get to reading, I think. As a matter of fact, I sat down with one book and I was reading another one this afternoon, and I decided to get ready to come in here instead.
Well, I can only read for so long and my eyes start to drift down and it's hard to stay awake.
That's one reason I do my reading, is I can get to sleep.
That's right.
Sometimes,
That's right.
that's
Exactly.
when I do my reading, is at bedtime.
Yep, me too.
Well, anyway,
Yeah. Well, I'd say let's investigate on what we're gonna need for slit. That would be a good thing to check into.
okay.
And the other components, one thing I wanted to check is that, micrometer head, if that's gonna fit in where it needs to fit in.
That's in this box here, and it goes like right here, right?
Okay.
Maybe.
All right, let me see if I can.
Yeah, they're probably gonna need to do a little bit of cleanup on some of it.
Well, and I'm not even so worried about that as I want to make sure that micrometer head is correct, that it will actually work because I have kind of limited choices here. And there's the micrometer head. Here, I'll scan that one. That's our micrometer head we're going to use.
Do we still have people out there?
Yeah.
Oh, hey.
Hey,
They at least left their computer
all
on.
right, now where did you say this went? Is that right in here,
No,
there?
I don't think that's right now that I look at it. Let's see. Let's go back to the browser here.
Probably about 12,000 individual pages we can go through.
You want to step on it? Do that.
That didn't work. Why is there more than one thing called low spec?
It is hard to find it. It's like on Thingiverse.
Is that where you saw it? Inverse?
There you go. There's 48 files. I guess maybe one of them will work.
Yeah, some of those are the printing files.
And you might be looking at, oh, let's see. You're probably on an older version. Or maybe.
So there's the slit plate. right
Plate,
there.
yes. Slit plate, not the slit.
And that's this.
Yeah.
Right. So the slit itself is something we need to.
Yeah, and I assume that the slit is one line, and you could use these different bases to get in bigger, brighter stars to fit in, and then you line that up and then shoot that star up that slit.
Right.
At least that's as far as I think it is.
So it looks like the micrometer head.
Oh, yes, it goes on the side here.
Yeah.
On this side. Looking at it this way. And right there is where that goes. And we may have to widen that out a little bit.
It should probably fit pretty snug though, I guess.
It's gonna fit a little too snug, but we probably need to clean it too.
Yeah.
And I'll have to, when we start putting this thing together, I'll bring out some micrometers and that sort of thing. somebody to calibrate it, because that doesn't look like. The hole looks a little bit small for the head I got here, so we may have to modify that a little bit.
Yeah. Well, some of the stuff people are doing with these is pretty impressive. There was some group that was actually participating in a radial velocity survey.
Yeah.
That seems pretty cool.
Anyway, okay, those, and then there's, I'm really down to the nuts and bolts of it, frankly.
Oh,
Really. It's, you know, what happens when you get old like me. So I say nuts to that.
Here's the.
Yeah, there we go. I'm looking for the pack of. Oh, here they are. Way down at the last thing I pull out, of course. So there's 25 bolts in here, and most of these get cut.
Okay.
So, and I need to work on doing that. That's probably one of the things that I can get done early before we start. I just got those in when I brought this to you, so I hadn't had time to cut them.
Maybe one of the things I can probably do is just do a kind of an inventory to make sure that we have everything we think we have.
Yeah. I think that the head on that micrometer is bigger than what they called for here. I had a lot of trouble trying to find the correct micrometer with the right travel. So anyway, we can make that work. I don't think there's an issue there, but I just have to change the diameter of the hole a bit.
Yeah.
To see, it's got that head on it, and maybe that'll come off, but I doubt it. That's probably part of it. It'll go about a half inch. So anyway, this is kind of stuff that we can get started on and get these out of the way.
Yeah.
I'll take these home and I think I probably can. Probably can find another copy of that material sheet somewhere in this.
Yeah, I think if you download the files from that Thingiverse site, that's included in it. And it comes with all the files for printing and all that sort of stuff.
Yeah. So that gives you a pretty fine measurement.
I corresponded for a while with a guy that he's some Canadian university and built one of these things. I think he's on the physics department and he built one. I should probably reconnect with him.
I kind of remember seeing a paper from him.
Yeah, he was on one of the AEVSO, one of those Saturday things that they do, and
yes,
I asked some question in the.
It was probably one I had to miss because there was another one going at the same time. I
Yeah,
hate when they split those up.
I know. Anyway, that might be a good connection for us to sort of reestablish.
I talked to a woman by the name of Lauren. You won't be able to come up with her last name, but she was at the AEVSO meeting, and she is one of the spectroscopy speakers.
Oh, is she kind of a young?
Harrington, something like that.
Is she kind of a really young girl? And
Yeah, she's young. I'd say about 28, 29. To our age, it's everything's young.
Yeah.
But
Does she wear like a tie-dyed shirt?
yes.
Yeah, she's
Yes.
the one that hosted this thing.
Well, she moved to northern Oklahoma.
Oh.
So I've been in touch with her, and I told her that I just sent her an email today. Told her a little bit about us and about our stuff and what we've got available. I said, check us out online. And also, if you decide you want to do this, we'd love to have you come talk and give a talk about this sort of stuff and spectroscopy in general. She's just avid about spectroscopy. So
She did a really interesting one. This was, I don't know, more than a year ago, but one of those webinars that they do, and she did a really interesting one about, her equipment was like a Dobsonian and one of those star analyzers,
and
the
she was
slitless.
able to stack those images, fairly rapid images, and stack them. And so, she could stack them on top of each other, and we got some pretty respectable spectroscopy out of it.
I know, it was pretty impressive. Yeah.
So-
got it.
So anyway, I'd like to get her to come up and give us a talk, and then I hope she would join the club, because her option is, Tulsa doesn't have a club that I know of. And I think Oklahoma City is her closest one from there, and that's quite a ways for
That's
her.
not too
It's
close.
probably as close to us. We're probably as close as Oklahoma City is for her.
Wichita.
Well, there is Wichita, but they don't do anything like this.
That
Neither
would-
do we, but
Yeah,
hopefully we'll start.
that'd be fantastic. She actually is the one that hosts these webinars. for
Yes,
them. So
yes,
she's pretty,
Yes,
I'd say, yes, by all means, let's,
and I'm trying to entice her to come up and visit us, so.
I think that would be fantastic.
I've got her card, so I
Okay.
stalked her down and tried to get some information from her. And when I found out that she was living in Tulsa area, and I said, where about in Tulsa? She says, oh, I'm way up near the Kansas line.
Okay.
And I said, well, that's actually getting pretty close to us.
Yeah, that's not,
125 miles maybe?
yeah, it's my Kansas standards. That's right next door.
Yeah, that's right. So anyway, hopefully we can get her involved and make her a member.
Yeah, that would be
Bring her in
fantastic.
here.
I would
She's
think-
very avid and very energetic.
Yeah,
So I think it'd be good for our club, actually.
I agree.
Anyway, okay,
All righty, well. anything else?
I'll get these cut to their proper lengths.
Should we adjourn then, or?
Probably so, because they still close the library at 9:00, I think.
Yeah. Well, thanks everybody for coming. Thanks those of you at home for coming in. I guess we don't have a meeting in December, right? There's no general meeting?
No, there's no general meeting, it's just the Christmas party.
Right, so the Christmas party is the 5th, right? 4th. Saturday, the 4th.
Yep.
Okay, and that's at the Snyder Cabin?
Yep.
And hope to see people there.
At Gage Park, Snyder Cabin.
Okay, well, we'll hope to see people there. And we'll resume general meetings in January.
Yes. And hopefully we can get Lauren in here and talk.
Yeah, that would be super.
Hey,
Yeah, she's,
she's a dynamo. She's
Yep.
she's a busy woman.
yep. Okay, well, thanks everybody again, and we'll see y'all hopefully at the party.
I'm gonna give you all that back
You want me to
because I
hang on to
think this is all I need for now.
Okay.